Welcome back, Year 8. So today we're going to continue looking at the same learning objective that we've been looking at in the last video, which is the differences between the types of rocks. So in this video we're going to be looking at igneous rocks. So already, can you remember what an igneous rock is? Whenever you think about an igneous rock, probably the first thing that you should be thinking of is a volcano. So as we can see, here's a volcano. This is one that has just erupted. So you can see all of the ash cloud that's come from that really, really hot lava. You can't actually see the lava because the lava from this volcano has already been kind of spewed out the top and then it's run down the sides. So with this eruption, the volcano actually erupted a few hours earlier. So if we zoom out a little bit, you'll be able to see that's me. So here I am here. So yeah, I was lucky enough to be able to climb the neighbouring volcano and very, very lucky to watch this volcano, it's called Volcano Fuego, actually erupt overnight. So when it was erupting, it looked something like this. So exactly what you imagine when you think of a volcano erupting, and you can see all the lava flowing out of it. Another very cool thing that we got to do, thinking about rocks, is on the way up, we got to melt some marshmallows on some hot rocks. So after the lava spews out of a volcano, so if we look here, and rolls down the side, it takes a long time to cool because it's very, very hot. So it takes a few days for it to cool down. So we were able to find some of the rocks that had, or some of the lava, I guess, that had spewed out a few days earlier that was still cooling down and yeah, melt some marshmallows on it. So that was a very delicious experience. Quick recap on this one, that hopefully you can all remember this. Magma and lava are both molten rock. So they're rock that has been heated up so high that they've turned to a liquid. So we call it molten rock. Magma is the name we give to molten rock that is underneath the Earth's surface, so here in this picture. And lava is the name we give to molten rock that is on the Earth's surface. So one that's already been, I guess, spewed out by a volcano. Okay. As I said before, I got to melt some marshmallows on some hot rocks on the way up to the top of the volcano. What type of rocks do you reckon I would have been melting these on? Yeah, so they would have been igneous rocks because igneous rocks are the ones that are formed by the cooling of magma or lava. So in this case, I would have been melting the marshmallows on cooling lava that are developing into igneous rock. Now we give igneous rocks two different names, and these have to do on whether it was magma that cooled, so they cooled inside the Earth's crust, or it was lava that cooled, so it cooled outside the Earth's crust, on the surface of the Earth. And we call these intrusive and extrusive rocks. Which one of these do you think relates to the cooling of magma? And which one do you think relates to the cooling of lava? Have a look carefully at the names. Intrusive, and let me change the colour. Extrusive. They should give you a bit of a hint. So, extrusive igneous rocks are formed by the cooling of lava on the outside of Earth's surface, whereas intrusive igneous rocks are caused by the cooling of magma here, within the Earth's surface. So there's our difference. So you're probably wondering why it matters. Why does it matter if a rock cools inside the Earth or outside the Earth? Why does it make it different? Well, the answer is it all has to do with crystals. As lava and magma starts to cool down, crystals start to form. So you would have seen some rocks before that kind of look a little bit sparkly. These are crystals that are in the rock. So crystals are when the minerals in the rocks, or the compounds that make up these minerals, join up in a very specific geometric type pattern. And we can look closer into this in class in a few lessons' time. Now, the way that the crystals will actually grow and whether they're big or small depends on the speed at which the magma or lava cools down. So, intrusive rocks are ones that cool within the Earth's crust. So within the Earth's crust, it's still very, very hot. This means that the magma is going to cool really slowly. So I'm going to put here, cool slowly. When it cools slowly, this means the crystals can grow really big because they have a lot of time to form. So in an intrusive rock, it's going to cool slowly and the crystals are going to be big. Whereas an extrusive rock here, they cool on the outside of the Earth's crust, so it's not nearly as hot. This means they're going to cool down a lot quicker, so they're going to cool down quite speedily. And conversely, because they're cooling quicker, their crystals are going to be very, very small. All right, cooling quickly, crystals don't have a lot of time to form, so the crystals are very, very small. Final slide here, guys. I know there was a lot of information on that last slide, so this is kind of a bit of a summary slide. It also gives you some examples. So basalt and obsidian are good examples of extrusive igneous rocks. Now these are found on the surface of the Earth. They're cooling quickly, and so they have small crystals. Whereas over here we've got our intrusive rocks, and granite is an example of that. So you can already see sort of the sparkly bits in this, which are the larger crystals. And that's because it's cooled down quite slowly, because it's within the Earth's crust. So a lot hotter inside the Earth, so things aren't going to cool down quite as quickly. This could be a really good slide for you to write down into your notes as a summary about extrusive and intrusive igneous rocks.